All right. Hello, everybody. How we all doing? Yeah, we're doing this thing again, right? Running it back on the full classroom. Start down here at chapter 13, which I mentioned before break is on solutions. It was also the most recent lab that we did right before break as well, right, with the copper sulfate, and you're making all those solutions in those volumetric flasks. So we're talking solutions. It's a really cool chapter. It kind of sets the stage for a lot of what we're going to be doing for this, the remainder of this last, semester, quarter and a half here. Yeah, just in general, it's a pretty interesting unit. It's a little bit more math heavy, so we're going to be spending some time doing a lot more equations and formulas and whatnot with this particular chapter. So make sure you're prepared for that. At least for the majority of the equations you're going to be running into with this chapter. The nice thing about it is that they're all in our handy dandy reference table. So that table T is going to come in handy quite a lot when it comes to this unit. And we're also going to be running into a couple of new additions to our periodic, to our reference table as well. A couple new tables and whatnot to look at to help us understand and do some problems. So without further ado, let's get right into it. So the very beginning of chapter 13 right here is going to be mostly a lot of vocabulary words. So it's going to be a lot of vocab. We'll focus more on the equations and whatnot in class. So we'll focus on doing a lot of the sample problems and equations and whatnot in class. I'll introduce you to the equations on these videos, but again, I want to do them in class with you so that we have class time to do all these sample problems together, so we all have them are on the same page with that stuff. So without further ado, let's get into some of the vocab. So as a solution, of course, we're doing a unit on solution, so we should definitely define solution. It's going to take into account some of the concepts we've learned early on in the school year, right? So words like homogeneous, words like mixture, right? These are all words we learned way back at the start of the school year in chapter 3. So a solution is a homogeneous mixture of two or more substances with the particles evenly distributed, right? And that was a phrase I used a lot when talking about a homogeneous mixture, evenly distributed, right? So we're thinking about things like salt and water, right? When you mix salt into a cup of water, right? The salt particles are evenly distributed throughout all of the water in that particular cup, right? It's not like sand in water, where no matter how much you mix the sand into the water, it's never going to dissolve, right? So you're able to see that clear distinction between the sand and the water. That would be a heterogeneous mixture. We are talking about homogeneous mixtures, right? Which are also called solutions. Now, whenever you look at a solution, solutions are broken down into different sort of pieces, right? And one of those pieces is called the solute. And generally speaking, the solute is a solid. It's your solid that you're going to be putting into your liquid, right? And you'll see what the name of that liquid is called in just a second. But your solute is a substance that gets dissolved. It's a substance that is getting dissolved, right? Whereas the solvent is a substance that the solute is dissolved into, or essentially does the dissolving, right? So if we use our example of salt in water, your solid solute is going to be the salt you pour into your cup, whereas the solvent is going to be the substance that is doing the dissolving, in this case, the water, right? So your solid solute is getting dissolved, salt, and your solvent, or water, is doing the dissolving, right? So you're mixing those two things together. And when you add solute plus solvent, you get a solution. So it's almost like a addition problem, right? Solute plus solvent equals solution. Now, there is something called a suspension, which we won't really spend too much time talking about, but I do want to, at least define. But a suspension is a heterogeneous mixture of two or more substances with the particles in distinct separate layers, right? And that's where that idea of heterogeneous comes from, right? That distinct line between the particles you're mixing and the solution or the solvent you're trying to mix it into, right? A good example, again, of that is your sand and water, right? Sand and water. Now, some more vocab continued. A soluble substance, right? So soluble is a substance that is able to be dissolved in a solvent. Sometimes there are solutes that are not able to be dissolved in certain solvents. And we're actually going to be focusing on this idea of solubility. You might have heard about this word solubility before, something being soluble in the past, and we're actually going to talk a lot about this idea of solubility. This is where this word soluble comes from, a substance that is able to be dissolved in a solvent. Insoluble, on the other hand, that prefix in, is it where a substance is unable to be dissolved in a solvent, right? It's the complete opposite of soluble. So if something is able to be dissolved in a given solvent, it's soluble. If something is not able to be dissolved in a given solvent, it is insoluble. Soluble, insoluble, right? So a little bit different there. Now, a couple of differences here are that, well, what happens if the two substances you're mixing together are liquids, right? That's where this idea of miscible versus immiscible comes in, right? So if a substance is miscible, it's a description of two liquids that are soluble and will mix together, right? So think about two liquids like water and white vinegar, right? If you try to mix water and white vinegar together, they're going to mix together very, very evenly, right? They're going to dissolve and are be soluble with each other. Now, immiscible is a description of two liquids that do not mix or are insoluble. I'm sure you guys can think of a lot of examples of that, right? Oil and water, oil and vinegar, right? A lot of good examples right there of two substances, two liquid substances that do not mix together, that are not soluble and do not mix. That's immiscible. And again, right there, oil and water is a great example of that being the case. And lastly, but certainly not least, is this word aqueous here. We've run into it in the past, and it is a word that aqueous is a word that we're going to see crop up a lot from here on out now. Okay, so we have to make sure it's a vocabulary word that we have definitely under our belts and we are very, very familiar with. So aqueous is a solution with water as the solvent. Okay, plain and simple. There are tons of different solutions out there in the world that, you know, scientists and people can make. You can make solutions of so many different things. But an aqueous solution, a solution with that little AQ in parentheses, right, is a solution with water as the solvent, right? Water is the thing doing the dissolving. Pretty much all of the solutions we've used in the lab environment, guys, are all aqueous solutions. They're all using water as the solvent. There are times where that's not the case, right? You might use a different substance or a different liquid substance as the thing doing the dissolving, right? A different solvent. But for the purpose of what we're going to focus on in this class and spend a lot of time talking about, water is going to be the solvent 99.99 times out of 100. Okay, so it's going to be very, very consistently water as our solvent, which means a lot of the solutions we deal with in this class will be aqueous solutions. So if a solution has water as its solvent, it is an aqueous solution, right? So if water is the solvent, it's an aqueous solution. Now, solution concentration, that's basically where, you know, a lot of the big concepts, especially a lot of the calculations come into with this chapter, right? And something that was kind of briefly touched on when we were doing the most recent lab, right, before winter break. So solution concentration. You guys are hopefully relatively familiar with the idea of concentration. If something is really, really concentrated, that means there's a lot of something in that solution. Where if something is not very, very concentrated, then it's not going to have a lot of that, right? So think about, I don't know. Let's think about like those Gatorade packets, right? Or Liquid IV, for example, right? Those packets of Liquid IV or packets of Gatorade. If you pour in like a very, very small amount of your solid Gatorade or Liquid IV particles into your water bottle and you shake it up, you take one sip, it's not going to be very concentrated, right? Because you didn't put a whole lot of those dissolvable powder into your water, right? But if you pour the whole thing of Liquid IV or Gatorade powder into your water bottle and shake it up, it's going to taste way better because you're making your solution more concentrated. Your solution is Gatorade powder and water, right? So depending on how much Gatorade powder you put into your set amount of liquid water, that's going to depend on how concentrated your solution is. So it's a measure of how much solute is able to dissolve in a given amount of solvent, or essentially how much stuff can be dissolved in the liquid. That's a very, very basic way of saying what concentration is. Now, there are ways to describe a solution as, you know, in terms of its concentration. If a solution is dilute, that means there's a very, very low concentration. There's only a little bit of solute per unit of solvent, right? So if you put a little bit of Gatorade powder into your water bottle, okay, it's going to be a very dilute solution, right? Very low in concentration. If you have a concentrated solution, that's quite the opposite, right? That's like as if you put in one little water bottle, you put three little packets of Gatorade powder into your water bottle, right? So it's going to be a very, very concentrated. It's a high concentration, or as in a lot of solute per that unit of solution. Now, there are tons of different ways to measure concentration, and we're actually going to be doing all of these. We're going to be measuring it via percent mass, percent volume, which we're going to be the ones that we focus on the next slide here, molarity, molality, and then the last one here called parts per million. And again, we're going to talk about all 5 of these different ways to measure concentration throughout the next week or so. Starting with the first ones here called percent mass. Now, percent mass is going to actually look very, very familiar. It's going to look very similar to one of the equations we've dealt with in the past, because it essentially is a very similar type of way to calculate something we've done in the past. So percent mass is the ratio of solutes mass to solutions mass. So you're comparing almost like a part to a whole. So it's going to be kind of like that percent composition formula. Particularly though, it's going to be slightly adjusted to make up for some of the newer things we're talking about here. So percent by mass equals grams, that's what the lowercase g is there, grams of solute divided by grams of solution multiplied by 100. And actually, we're definitely not multiplying by 100 here, so let's actually get rid of that 100. We're not multiplying by, or sorry, we are multiplying by 100, but we are not multiplying by 100%, okay? I have to make sure I get rid of that. So we are not multiplying by 100%, we are just multiplying by 100, okay? Not 100%. Now, percent volume, okay, it's another very, very similar solution, or another very, very similar equation, okay? Percent volume is the ratio of the solute's volume to a solution's volume. So it's when you're comparing 2 different liquids this time around, as opposed to a solid solute, and a liquid solution. So it's essentially the exact same thing. So instead of using grams, we're using volume instead. So percent by volume equals the volume of the solute divided by the volume of the solution. And I again want to get rid of the percent sign here, because we are not multiplying by 100%. We are just multiplying by 100, because I know with a lot of your guys' calculators these days, if you try and actually multiply by literally 100%, it's not going to give you the answer that you need. Make sure that we, especially when we're inputting it into our calculator, we are not inputting 100%. We are just inputting the number 100, because that's going to give us exactly what we need. Okay, so the number 100 is what we're looking for. That's the end of the video. Thank you very much. I'll see you guys in class tomorrow.